This is Lab 9 by Chelsea Sizemore. The objective of this lab is to analyze and track a spring motion and calculate the potential corresponding change in the spring potential energy. The main result that we found was it is easier to calculate when the surroundings is doing no work on the system, but you need to add a potential energy to the system. I then used the video of Dr. Greco with the spring and tracked it in Tracker. I made the calibration stick 0.7 meters for the relaxed length, and the time length between them was 1/10 of a second. The mass of the ball was 0.402 kilograms, and it's pointed in the negative y direction for the axes. As you can see from the graph formed, it shows the spring oscillating. These are the equations used in the code to show the spring oscillating. To find the period, it is the length between the peaks of wavelengths. After you find the period, you can find the Ks. I used the formula 2 pi divided by square root of Ks over mass to find the Ks, since we know the period and the mass. Once you know the spring constant, you can find the compressed length and force. I then updated my code using the equations from above of the potential spring energy, kinetic energy, and potential gravitational energy. Then I ran the data, and the model runs like this. The blue ball being the tracker data and the yellow ball as the model. Then I used the data from Tracker from the model to make 3 graphs, one for the x value, one for the y value, and one for the spring potential energy. As you can see, they are all fairly similar and all are oscillating. What does it mean? For part 1, it asks to compare the oscillation from x component and the y component. The x had a shorter oscillating motion than the y because it had a bigger displacement. In question number 2, the energy principle is delta E equals work plus transfer of energy. In the system before, in the part 1 lab, it was mass plus earth, but in this lab, for the system after, it's mass plus earth plus the spring. We added the spring into the system because then the surroundings would do no work on the system, making the energy principle equal 0. Thus, work would equal 0, and that is why we had to add in the spring potential energy to the system after. In question number 3, the y position would change, but the x position did not, but it did make the graphs have a bigger wavelength and amplitude.